Hello and welcome to this video where I will show you how you can benefit of using parts and assemblies in Revit and work a bit smarter. So in the end, hopefully you'll be able to create your delivery plans with some tags on the different elements and also element list taken out automatically from this Revit model. Also, I will show you how to create delivery plans. Again, we can add information to the different assemblies so we can see which element should be delivered on site in which number. The example I will use will be on concrete element, but that could also be used if you're working with wood elements. So what I have here is the architect's model, and another model will be the engineer's structure model, in this case TTS beams. So I close them down both and create a new project, because now I'm the manufacturer of these, in this example, concrete elements. So I'll start up a new project, and I'll start by saving this as the manufacturer's number plan or delivery plan. So I start by inserting the architect's model, in this case including only walls. The positioning will be origin to origin, and because of the positioning is the same as the structure model, I can then import the structure model as well, and that will then fit on top of the architect's model. So what we see here is the architect's model and the engineer's model. So we actually have nothing in our own manufacturer model, you can say. But we'll use, for example, the grid lines from the architect's model. There's a different ways of copying the architect's model. Grid lines, sorry. You can use this copy monitor, but I will instead I'll create my own grid lines using pick lines. So I pick all the lines that I have, or all the grid lines that I have from the architect's model. I could log them together so that if the architect changes something with the grid lines, they will automatically be updated in my project. So you can see if I unload the architect model, you can see I have in fact nothing in this model but my grid lines. As mentioned before, I can log grid lines to the architect's grid lines. If I create a section in front of this wall, looking at the wall from the inside, what I can do with my levels, I can do the same. So I can move them up, I can log them so that it is logged to the architect's level. So if anything changes, if we get a new model or whatever, we can then log things together and update them. So since the wall that we're looking into here is supposed to be load bearing, the TTS beam must be placed on top of the inner leaf of this external wall. So to find that specific height of the inner leaf, I'll create, as you see here, I'll create a reference plane showing the top of my inner leaf. And I can name it. Then I can find this reference plane later on if I want to use that as a working plane. So now I would like to convert this wall, or these walls that I have here, into parts. So as you can see, when I select this wall and press parts, I will get not only parts but also the original wall. So I'll select all 4 walls as you see here and convert them into parts. So note that we have now created a copy of the architect's wall, converted them into parts. So as you can see, when I unload the architect's model, actually it will disappear until we change the part visibility from showing its original to show parts. Actually, those parts that we have here are the only objects that we have in the model. The TTS beams is still a linked model into this. So since this wall have 3 layers, when it's created originally, the 3 parts will be available for adjusting. So as I mentioned before, I would like to have that the inner leaf is its top of the inner leaf will go to this reference plane that I made before, and I can log them so that they if I move the reference plane, then those adjustments that I make here will be followed by the reference plane. So what I do here is I'm adjusting all 4 walls, all inner leaves on the 4 walls. So before I do that, I create 3 new sections. So I have a section in front of every wall that I have here. That make it much easier when I select and adjust the inner leaf and the insulation part. So now I have adjusted all the inner leaves and all the insulation so it fits to the underside of the TTS beams. So now I want to split all the wall or the parts elements into different wall elements. So I select all the parts and divide them by using the grid lines that I have in my model. So instead of levels, I use grids, and I want to use all of the grid lines except in my model grid line number 14 and 21, because I want to have a special element in those 2 corners. So I uncheck 14 and 21. And then you'll see that all the parts will be splitted with a gap of 32 millimeter. In this case, as you can see here, as I mentioned before, I would like to have a special element on this corner. So if I select those parts that we have around this corner and then make a special 3D view of that corner so I can see it better, then you can see I can begin to merge the parts that are splitted up before, because this corner actually came out of 2 original wall elements and I want to merge them into one. So I can select the different parts elements and turn them into one element. And that is just by holding my control key, selecting the 2 parts, and then I merge those 2 parts. So now instead of having 6 parts around this corner element is now 3 parts, as you can see. If we go to the plan view and select those 3 parts, you can see also here that now it's 3 individual parts instead of 6. So next step will now be to convert those parts into assemblies. So I select the 3 parts of this wall and click New Assembly. It will automatically create type 001, and if I select another 3 parts, it will automatically name it number 2 and so on. Now you can see this is the exact same geometry as number 2. So the assembly will find out that if we have 2 identical assemblies, it will get the same name. So here we have some parts, some assemblies. I can start by turning those 3 parts into an assembly, also here on the section. And when I create this new assembly, it will have part number 3. And if I do that the same on an identical parts, turn them into assemblies, you can see that we will get the same name. But if I begin to adjust some of the parts or assemblies, then you can see here that it will have a special name. Revit will automatically find out that if there is a difference in 2 elements, then it will be renamed. In this case, we have a TTS beam going into the wall, so I'll create a cutout in this part so that this element will be special. I'll show you in the end of this video, I'll show you how you can create those voids if you want to cut out the geometry where the TTS beams will be placed in the walls. So I'll copy those 2 voids that I have here. And again, if I isolate what we're looking into here, and I turn off the structural engineers model here, so we only see what is in our model here. So we have the inner leaf, we have the whole assembly here. So if I select the inner leaf and I cut away where the TTS beams is supposed to be, then it will give me a warning saying that this element is not this or cannot have the same name as the one before. So now this element will be unique to the project. It is possible though to rename the assemblies that we're creating on the way. So we can select an assembly and press edit type, and then we can rename those assemblies as we have here. So now we consider that everything about the 3D model is now over. So now we'll have a look at how to create the documentation output that you need to do. For example, the number plan. So I copy level 1, name it number plan, and then I'll make it visible which element we have and where we have them. So I'll add some tags under the den edu, and under annotation you can add the assembly tag if it's not a part of that specific template you're using. So I'll add the assembly tag to this view. As you can see, it will give me a question mark, and that will be because if I select the assembly, there's no data in the mark value. If I change it to comments, it's the same. So if I select the assembly, there's no information in the comments field. So I want to have that element 004 will be a part of of this tag or should be visible on the floor plan. So I select the tag and edit the family, select the comment label and press edit. So I'll have both the comments parameter value and the type name, and it should be placed on 2 lines, so I'll check break line. That will then give me the information about the element name, but since there's no data or parameter in the parameter field comments, then it will be empty until I add something. The comments field could be used to, for example, adding the delivery number. When is this element supposed to be delivered on the site? So that is why I write delivery 1 or DEL1. As soon as I add information in the comments field, it will be added in the tag. If later on I will create a new floor plan showing something about the mounting, which element should be delivered on the site, in which order, I can create what we can call a delivery plan. On the delivery plan I'll make it very visible using colors so that I can see which elements should be mounted first, and very graphically by using colors. So under filter, I'll create a new filter called delivery 1 or DEL1. The categories should be assembly, and the field that this filter should look into should be the comments field. Every time it equals DEL1, it should do something. In this case, it should override the cut pattern and the cut pattern's color. So now you can see that the delivery element number 1 turns red. And if you want to continue doing this, then you need to duplicate that specific filter that I made and then apply it. You can, of course, create facades or elevations, and since the information is on the assembly, it's just by adding tags to this view. And there's also a place where you can say tag all, so you don't need to place a tag one by one. So if I add this number plan to a sheet, I will also have a schedule showing the different elements that I have and how many do I have of the different types. So I'll add a schedule including comments, count and type, and I'll have type as the first column. Then I'll get a list of all the assemblies that I have in my project. That specific schedule can then be placed on the sheet. I can arrange the schedule so that it will show not a row for each element that I have, but it will add together how many different elements I have of the same type. So under sorting, I can add a blank line, remove itemize every instance, and calculate totals on the count. That will then give me a count on how many different elements do I need to have on or in this project. I can, if you don't want to have comments or count or type or assembly schedule, you can double click and rename into your if you want to have your own headlines here. So that was actually what I want to show about parts and assemblies. Hopefully you can see the benefit in using those in this phase, in this manufacturer phase. So early on I promised you that I will show you how to create those cutouts here, those voids for the TTS beams. So I'll do that now, and I'll close this example here and start one from scratch. So in general, when you create new families, there is a huge part on my YouTube channel where you can see how to create different types of families. But I'll create a face-based family in this case, so it will actually glue to the face of my parts or my wall in the project. So every time you create a new family, start by creating some new reference planes and make those reference planes equal distance to the center of this template. So I'll create a couple of dimensions as you see here, and since the shape of this void that I'm creating now has some special dimensions or different dimensions in the top and the bottom, then I need to create a couple of new dimensions here below as well. Then I'll create a couple of parameters so that it should be possible for me to change those dimensions in the project. So I'll create a couple of type parameters here, and that will be width at the bottom and width on the top and a height and also a thickness a bit later on. And before I create the geometry, I'll check if those parameters that I have just made, are they working? So if they're not working, as you can see here, they're working. So when I move them or using my arrow keys on my keyboard, they're working. So they will actually change when I move them or if I change the dimensions here. So before I create the geometry, I check if they're working. And as you can see, they're working. So I can move on by creating the geometry now. So under create and under forms, I'll create a void extrusion. So I'll start by creating the boundary of this void. And then it's very important to log it to the reference planes, and I do that by moving it a bit away from the reference plane and back to it, and then log it. And again, before I finish it, I'll check it again to see if it's actually working. So have I forgot to lock something together? So again, if I select the reference plane and I move it, you can see that the geometry is now locked to the reference planes. So everything is okay here now. I'll just change the dimensions back because now I have moved them. So back to what they originally were before. So if I go to one of the sides, if I want to control the thickness of this void, then I need to create a reference plane and lock the reference plane to the geometry. So I create a new parameter here called thickness. Again, it's a type parameter because I want to control it once and for all when it's in the project. So now we have found out that it's working, so I'll save it. Always a good idea to give it a good name so you can reuse it and find it again. Load it into the project and close this family editor, and then let's see if it's working. So it looks like it glues to the face. So when I try to use the cut tool, it doesn't work. I forgot something. So I select it and say edit family. I need to check over here, cut with voids. We need to remember that. So now it should be working. Thank you for watching this video.